Okay, hello. My project was on basically extending Project 3 and um, allowing for like more different ways to analyze PDFs and the different ways that you can, similar to like the Benford app API. I thought it was kind of cool to continue like working with PDFs. So much like the Benford app that we were doing before, um, we still have event-driven serverless applications. And so, like in the Benford app, uh, two of my newest functions, which is analyze readability and calculate word frequency, are event-driven on uploading the PDF. And so I know compute for Project 3 had also been event-driven on that same instance, and this is exactly the same event that drives both of these. And then new this time though is merging PDFs, which is event driven on uh, uploading two PDFs. So we'll see how that works in a bit, but basically the Lambda functions are all still event driven, and yeah, we're relying on the Amazon Web Server. Uh, yeah, so I guess talk about the first function, which is called analyzing readability. And so I kind of got inspiration from the Benford app, and I thought this was really cool. I was looking up ways to see how we can analyze documents, and the Flesch-Kincaid reading ease formula basically calculates how easy a document is to read. And just so I'll go into that, and I think it's actually really cool. But yeah, basically I use the old Project 3 compute function to do a lot of the analysis, and I save a lot of that to my database. And then I finish calculating the score within my Project 3. Project 3 calculate readability. So yeah. Yeah, so my next function is calculating word frequency, which, like last function, was event driven on inserting a PDF or uploading a PDF, and basically will sum up all of the words in the PDF, store them with an example of them being used in the PDF in a sentence, and calculating, storing the number of times it was used as well. So this is all kind of done through adding it to my word frequency table in my database, and because I was able to store it in the database, I'm able to collect like the highest frequency words and the n highest frequency words, and so that's what my Project 3 calculate word frequency does. Is it takes in the number of highest frequency words we want to see and the file name and gets the highest frequency words. And lastly is merging PDFs. This was an example in one of in the final project doc that I took, but basically it's event driven on passing in two PDFs into our merge function, and our merge function decodes the PDFs that we've obtained from the client, utilizes PyPDF's PDF merger to merge the two PDFs together, and then encodes the merged PDFs and sends them back to the client, where they'll be automatically downloaded. So I'll do a demo now of my code. So the three new functions here are analyze readability, calculate word frequency, and merge local PDFs. So with analyze readability, you can take any document that has been uploaded to that has been uploaded previously, and you can see. I will open this up before I show. I closed it. Okay, that's annoying. So this document here, don't look too deep into it, is actually a contract for my organization that I'm doing. It has some fairly big words that make it difficult to read, and so we would expect a low readability score on the Flesch-Kincaid score. So like I was doing before, we can go ahead and type in, so this is document.pdf, and it will calculate the readability score. And like I was saying earlier, higher score is easier to read. So 14.2 is not very easy to read. If you can see, it's in the latter end of what would be considered an easy score, or a harder score. And we're gonna go and compare that actually with, if you've ever read The Very Hungry Caterpillar. Obviously, it's a children's book, so you should expect a very high readability score, because what's happening is basically the Fletcher-Kincaid score is calculating based on the syllables and the sentence length. And so we can see right here, if we give that one a try, hungrycat.pdf. Okay, and you can see here that the readability score on this document is actually a 115, which goes off the scale for what is shown on this diagram. So basically that means it's really easy to read, and that'd be expected because it's a children's book. All right, so the next function I have is calculating word frequency. And similar to last time, you enter in any previously uploaded PDF. So we could actually try The Very Hungry Caterpillar again. And it'll ask you for the number of inputs that you, for the most frequent words. We'll just go with 10. And it'll display from top to bottom the most frequent words. He is the most frequent word in the Very Hungry Caterpillar, which is surprising because it's more frequent than hungry, and so we see a frequency of 14. An example sentence of where it was used: he started to look for some food, the very hungry caterpillar, but he was still hungry, and you can see it as it goes down and down. And so you can do this for as many words there are in the in the PDF. And lastly, we can do our merge local PDFs, which takes in two local PDFs. So we can do, let's just do the same documents we've been doing before. Document PDF is the first one, and the very hungry cat.pdf is the second one. And it will take both those PDFs and return a merged document involving both. And you can see that popped up on the side. Get a little confusing because some of the older documents, but this is document, the very hungry PDF merged together. So yeah, that's a demo for all of my different functions today. All right, thank you so much, and have a good day. Hope you have a good summer.